In question 2, we are going to take a look at remainder and factor theorem. Just a quick recap. The use of remainder theorem means that if a divisor is given to you as ax plus b, please equate your divisor to be equal to 0 and find out what is the value of x. In this case, will be negative b over a. This means to tell you that your remainder in this case, if the polynomial function is defined to be fx, your remainder will be equal to f of negative b over a. And that is what the remainder theorem is about. But in factor theorem, it's also very similar, except you will see the keyword called factor, or if not, exactly divisible. The concept is the same. Meaning, if I were to actually make use of factor theorem, the divisor, or rather in this case to be more specific, the factor must be given. If let's say the factor now is x plus b. So in this case, when you equate to be equal to 0, the value of x will be equal to negative b. This means to tell you if you substitute negative b inside your polynomial function, fx, your remainder will be equal to 0 because it's exactly divisible. Making of this concept, let us do our question 2 now. Take a look at question 2. Alright? An expression, a polynomial expression is given. Please define your polynomial function first. Next, you are told that it's exactly divisible by x squared plus x minus 2. Let me write down the factor. And remember, you will need it to be a linear factor. And you notice this quadratic factor can be factorized to be x plus 2, x minus 1. This means that there are two linear factors in this case. Alright? So, when your factor is actually equal to x plus 2, this means that the value of x is equal to negative 2. You can put the value of negative 2 into your polynomial function fx, and the remainder would be equal to 0. So now, very quickly, replace all your x by negative 2 and do your normal calculation. This is what I will obtain. Simplify the expression. 4a plus b would be equal to 0. That's for the first linear factor. Remember, you have another linear factor as well. Let us make use of the second linear factor, when the factor is equal to x minus 1. Same thing, make use of the factor theorem. Substitute 1 into your polynomial function, and this is what I will achieve. Simplify your equation, and this is what I will obtain. Notice there are two unknowns a and b in two pairs of equation. Your job now is to solve for simultaneous equation in terms of a and b. Let me equate the two equations together. I'm going to use elimination method very quickly. Equation 1, subtract equation 2. What is left? Would be 3a is equal to 9, and in this case, your value of a will be equal to 3. We also need to find out the value of b in this case. Substitute b inside. A plus 3. 3 plus b will be equal to 1. This means that your value of b will be equal to negative 2. And there you have it. We are done for question